Hello everyone, my name is Matheus Castanheira. I'm a master's degree student at the Federal Technological University of Paraná in Brazil. In this poster, I'm going to present to you the preliminary results of my dissertation. This work was developed utilizing Python. Python is an open source language and contains one library specific to the working of solar physics, called SunPy. To summarize, we can divide it into three parts: filter noise and method validation, apply PyFLCT in images of the active region, and analyze of the resulting velocity field. In the first part, we download the data. This data is of the solar surface in the continuous range by the instrument HMI on board the SDO satellite. In Italy, we select a box of the side 300 arcsecond centered in the active region. It accompanies the solar rotation. After that, we reduce the box to on the side 150 arcsecond, and the values of the intensity are inverted for the sunspot to have the highest intensity value. To remove noise, we apply the Gaussian filter, and to select the largest structures, the Fourier filter. Now with filtered images, we evolve it with no velocity fields for creating test images. Utilize two test images. We apply a PyFLCT function that will return a velocity field. PyFLCT is the wrapper function that allows us to use the code used in Fisher-Wells 2008, originally written in C. This function applies a technique called Fourier Local Correlation Tracking, FLCT, to estimate the proper motion of the region. Looking side by side at the image of the imposed velocity field and the founded velocity field, we can see that they are similar. Now, to a quantitative analysis, we can look at the heat map of the velocity field models and its angles. The velocity models is expressed in kilometers per second and the angles in degrees. By comparing the values obtained with those imposed, we can calculate a percentage error. We can see that we have a relatively high mean error for the models, 36.55%. In the angles, we have a low mean error, 7.78%. And look at the median of the values, we can see that most of the data has an error smaller than the mean error. Remember that these results are preliminary, and we intend the reduce of the values of these errors until the conclusion. Now in these images, we can see the method applied at two different times in the evolution of the active region. Unlike the imposed field we used, the real field is dynamic and changed over time. To finish, I would like to talk about the next steps that we are going to take until the conclusion of this work. First, we will apply the method to all collected images. After that, we will search for critical points and characterize them. And finally, investigate whether these critical points are related to high energy events that occur in this region. Today, that's what I had to present to you. Thanks for your attention. Any question or suggestion? This is my email, or talk to me in the event chat.